welcome to my channel. Now here we have a question to solve on the construction of a parabola. So the question that I'm going to use, I have it on my laptop and I'm going to read the question. The question says that the rise and span of a parabola are 60 millimeters and 140 millimeters respectively. Construct the parabola within the rise and the span. Find the focus point of the parabola. So that is the question. We are given the rise as 60 millimeters and the span is 140 millimeters. So we have to construct the parabola and also we have to find the focus point of the parabola. So let's go and see how this can be done. Now the first thing that we are going to do here is that we are going to draw a horizontal line. So we draw this horizontal line, okay, like this, and then we are going to draw a vertical line. So we draw a vertical line, okay, so we draw a vertical line, so like this, okay. So let's call this point where the vertical line meets the horizontal line, let's call it point O. Okay, then we are going to take a measurement of 70 millimeters to the right and to the left side of O. So 70 millimeters to the right and 70 millimeters to the left. So this is 70 millimeters here from point O. Then we also have 70 millimeters. So this is 70 millimeters to the right of point O. So let's call this point, let's call it point A. And this point is point B. So the total is 140. So AB is 140, which is the span of the parabola. Then on this line, on this vertical line, from point O, we take 60 millimeters up. 60 millimeters up. So this is 60 millimeters. Okay. So then we are going to draw a rectangle. So we use this to form a rectangle. Okay. So I'm going to draw a vertical line from this point B up so that we can complete the rectangle. Okay, so from point A, I will draw a vertical line like this. Alright, so then this point here, let's call it point V. So this will be the vertex of the parabola. Okay. So then the next thing that we are going to do is that if I label this point as point C on the rectangle and this point as point D on the rectangle. So we are going to divide this distance BC into a number of equal parts, also AD into a number of equal parts, and also OA and OB into a number of equal parts. So this is what I'm going to do. Since we have that BC is 60 millimeters, I will divide it into 5 equal parts. So 60 by 5 is 12. So it's 12 millimeters. So I'll take 12 millimeters. This is 12. 1, 24. So makes it another 12. We have another 12. Then 36. That's another 12. Then 48. So it gives us another 12. So we have this. So now, so for this one, so if I number this point as point 1, this is point 2, this is point 3, so this is point 4, and this is point 5 here. Okay, so I'm going to transfer this division to this side. So look at the way I'm going to do it. Just use your T-square. So mark it here. Okay, mark it here. Then come up to 3. So you mark it here. And come up to 2. So you mark it here. Then come up to 1. So we mark it here. So that means we are divided AD also into 5 equal parts. By number this as 1. So this is 2. This is 3. So here is 4. And then at this point A we have 5. So we have divided the line into line AD into 5 equal parts. Now, so we're also going to divide OA and OB into 5 equal parts. So I believe you know that OA is 70 millimeters and OB is 70 millimeters. So if we divide 70 by 5, that will give us 14 millimeters. So that's what we are going to use. So I will set my ruler like this, and then I will take 14 millimeters. This is 14. Then 28 makes it another 14. Okay, so I will bring it here. So take another 14, and then 28 makes it another 14. So the balance is 14. So I will also do the same thing here. So take the first 14. So 28 makes it another 14. Then I will come here. So this another 14, and 28 makes it another 14. So the balance is 14. Alright, so that is what we have there. By number this is 1, this is 2, this is 3, so this is 4. So we already have 5 at this point. So this is 1, this is 2, this is 3, here is 4, then we have 5 here. Okay, so now the next thing that we are going to do is this. So very, very simple. So join point 1 here, join it with point V, that is the vertex of the parabola. Join it with V, and also join 2 with point V. Okay, so join 3 with point V, then join 4 with point V. Okay, so coming to this side, we join 1 here with point V. So it goes like this. So we join 2 with point V. So we join 3 with V. Then we join 4 here with V. Okay. So now the next thing that we are going to do is that, so we take our T square. So coming to this side, so we draw a vertical line from 1. So to meet line 1 here. Okay. Then we draw a vertical line from here, from point 2 to meet line 2. So draw from 3 to meet line 3, and draw from 4 to meet line 4. Okay, so all this point where the line intersect, this is point 4, this is point 3, this is point 2, and this is point 1. So we also do the same thing on this side. So from 1, so draw a vertical line to meet line 1. Then from 2, draw a vertical line to meet line 2, and draw a vertical line from 3 to intersect line 3, and draw a vertical line from 4 to intersect line 4. So we join this together as we locate this point. This is point 1. So this is point 1. Here is point 2. Here is point 3. And this is point 4. So we take our compass, we take our French curve to join them. So we are joining to point 5 here, and we also join to point 5 here. So we take the French curve to do that. So with the French curve being set, so you adjust it to ensure that you have a perfect curve. So this is it. So if I draw like this, okay, so then I can connect this together with this point. So we have completed that part. So then coming to this side, so draw from here. Okay, so we connect this, and then so we complete it here. Alright, so we have drawn the parabola. So then the question says that we should determine the focus of the parabola. So what you need to do, so this distance OA is 60 millimeters. So from this point V, which is the vertex, so take 60 millimeters up. Take 60 millimeters up. So 60 millimeters. So this is 60 millimeters. So I will call this point. So I'll call it V1. Okay, so V1. So the next thing that you are going to do is that, so you join this point AV1, join them together with a straight line. Join AV1 with a straight line. So this is it. So join AV1 with a straight line like this. Okay, so the next thing to do is that we are going to bisect AV1. We bisect AV1. So you take your compass. Okay, so take your compass. I'm taking mine. So put the midpoint of the compass here at this point. So put the midpoint of the compass here at this point and extend it a little bit beyond half of this line AV1. So draw an arc here. Okay, so draw an arc here and draw an arc on this side. Okay, then put it at this point V here. Okay, so this space will not be enough, but I'm going to manage it. So that means we need to, so I'm not going to, so I will see it on the surface of this board. So let me adjust it so that you can see it. So I will see it on the surface of this board. Please, so make sure you do your own, that you are able, the paper is able to contain this arc that I'm drawing here on the surface of the board. Okay, so then you draw an arc to this side here. So I still need to come back to A because this arc has to intersect this arc on the drawing board. So I will draw this. Okay, to intersect the one on the board. So they have intersected. So I have the point here. I can see it here on the surface of the board. And then, so this is another point. So I'm going to join this together. So we join this together. Okay. So we join together like this. So draw this line. So bisector of AV1. Okay. So wherever the bisector of AV1 touches this line, this center line OV, will be the focus of the parabola. So this point here, so this point is the focus of the parabola, so we put F here. Okay, so it's as simple as I've done it here. So this is how to find the focus of a parabola with this method that we use. Thank you and God bless you. Keep on practicing.